Hello and welcome to another GCSE revision video. In this video we're looking at the AQA 8300 series of past papers. This is the May 2017 first paper in the higher tier. It's a non-calculator paper and we're picking up in question 24. Now 24a says work out the square root of 12 1/4 as an improper fraction. Okay, well one of the biggest mistakes people make is just to get overwhelmed by this idea that the square root of 12 1/4 is like, I don't know the square root of 12 1/4. How am I supposed to know the square root of 12 1/4? Well, if we take our clue from this improper fraction and convert the 12 1/4 into an improper fraction, then we'll see where we're at. So 12 1/4 is the same as 12 divided by 1 plus 1 over 4. That's 12 plus a quarter, which is 12 1/4. So that's equal to, if we make the denominators the same, we just multiply top and bottom by 4 and we'll have common denominators. So 12 times 4 is 48. So that's 48 divided by 4 plus 1 divided by 4. And now the denominators are the same, we can combine the numerators. So that's equal to 48 plus 1 divided by 4, which is equal to 49 over 4. So the square root of 12 1/4 is equal to the square root of 49 over 4. Suddenly that doesn't look anywhere near as intimidating, because we know from our surds that that's equal to the square root of 49 divided by the square root of 4. And we know from our times tables that the square root of 49 is 7 and the square root of 4 is 2. So our answer is just 7 over 2. Now try not to get big-headed flushed with your success and then try and convert that to 3.5. Because the question is asking to work it out as an improper fraction, and 3.5 is not an improper fraction. So don't go any further than 7 over 2. Don't be tempted to say 3.5 or 3.5. That would be a mistake. Okay, so 24b says work out the cube root of 16 as a power of 2. Okay, so the cube root of something is the number, in this case it's 16, raised to the power of 1 over 3. And how do we know that? Well, if we say that a cube is, say, a times a times a is equal to a cubed. So the cube root is what number, when multiplied by itself 3 times, will generate the original number. So if we want to say a to the power something, let's call it n, times a to the power n times a to the power n is equal to a, then a to the power n would be the cube root of a. So if we use our law of indices, then that's a to the power n plus n, n plus n is equal to a to the power 1. In other words, 3 times n is equal to 1, so n is equal to 1 over 3. So if n is 1 over 3, then that's the cube root. So a to the power 1 over 3 is the cube root of a. So the cube root of 16 is 16 to the power 1 over 3. But we want this as a power of 2, not a power of 16. So we can say that 16 is equal to 2 to the power 4. So but 16 is equal to 2 to the power 4. And if that's not clear, then you can just say 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So we've got 4 lots of 2's to make 16, or 2 times by itself 4 times. So this 16 to the power 1 over 3 is equal to 2 to the power 4 all raised to the power 1 over 3. Now we know from our law of indices that if we're raising something to a power, or if we're raising a power to a power, that's just the same as 2 to the power of 4 times 1 over 3, which is equal to 2 to the power 4 over 3. And that is the answer they're looking for, is 2 to the power 4 over 3. And if that's not absolutely clear, let me just explain why. Again, if I have a to the power n to the power m, we're basically saying this is a times a times a dot 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 n times, and then all that is timesed by itself, and times by itself again m times. So how many a's have we got? Well, we've got n a's, we've got m lots of n a's. So this is the same thing as a to the power m times n. That's assuming that we're doing it in that order. Okay, I hope you found that helpful. If you're taking your GCSEs this year, I'd like to wish you every success with your revision and every success with your exams, and I look forward to seeing you in another video.